Okay, in this example, we will show that there's at least two people with the same number of hairs on planet Earth. It's kind of a silly application of the Pigeonhole Principle, but it's a fun application, and that's the reason why we're doing this. Okay, so what we're gonna do for this problem is basically first figure out how many people there are on planet Earth, and that's about 7 billion. We're told that in the problem. And what I'm gonna do next is basically figure out how many hairs are possible on a human being. I'm going to put a maximum amount of hairs on a person, basically. So what I'm going to do is pretty much something like this. I'm going to have one circle where I put all the people in the world. So this is person number 1, person number 2, all the way up until we get to 7 billion people. So we're going to pretty much put them in a list. And we're going to put on another side the number of hairs that each person will have. So there's people with 0 hairs on their body, and then 1 hair, and then 2, and so on and so forth, all the way to some maximum amount. And hopefully this maximum amount is really big, but hopefully if we make the function, some 2 people will have to share the same number of hairs. Okay. Now it's kind of silly, but that's the way we're going to be proving it. We're going to show that the function cannot be one-to-one. In other terms, we're going to show that this first set is going to have a way bigger number of people than there are possible number of hairs. And so some people will have to share the same number of hairs, meaning some people will have the same amount of hairs on their body. Okay. So first, let's begin by estimating the population on planet Earth. And so the estimate is 7 billion. That's because of the problem. Okay, so that's the number of people on Earth is approximately 7 billion people. Okay, now that's step number 1. Step number 2 is going to be to estimate the amount of hairs on a person. And the way I'm going to do this is I'm going to design a perfectly round, like a sphere kind of a person. So there are no hairs, no hands, no legs, no nothing. It's just one giant ball of a human being. And I'm just going to take that whole person and just fill him or fill her up with hair. It's going to be hair everywhere. So, it's going to be a ridiculously kind of a large person. It just looks like a sphere, and it's going to have just nothing but hair. Okay, that's going to be my maximum amount of hair possible on a human being. Now to do this, I'm going to suppose that the person is 7 feet tall, and I'm going to suppose that he's pretty much perfectly round. So suppose that some person exists that is 7 feet tall and perfectly round. Okay, so the person is 7 feet tall and that person is perfectly round. So that person pretty much looks like a giant ball. Okay, it's a ball of hair pretty much. What I'm going to do next is estimate the surface area of this person. Okay, the surface area of a sphere is given by 4 pi r squared. And I'm going to transfer everything to inches. So in this particular problem, the radius of the person is going to be 7 feet divided by 2, which is going to be 3.5 feet. But I would like to make that into inches. So I'm going to multiply it by basically 12, because there are 12 inches in every foot. So this way the feet on top and the feet on the bottom would cancel out, and this would give me a radius of that person. And so the radius is going to be 42 inches, basically. So that makes the surface area of that person, A is equal to 4 pi times the radius, which is 42, and then squared. So it's going to be some big number, but whatever. That number is roughly, let's say, 7,056 pi. And this, remember, this is in inches squared at this point, okay? So that's the surface area of that person. This is how much skin they have. Now, each square inch of skin has about 10,000 hairs. So let's figure out how many hairs there are by multiplying the two numbers. So the person will have, approximately 10,000 times 7,056 pi hairs. Okay, so let's estimate what this amount is. Okay, roughly speaking, this number is equal to, in decimal form, 221,670,777. So let's say, roughly speaking, 221,670,777 hairs. So this is the maximum amount of hair possible on a human being. So that's pretty much our maximum estimate of hairs. Okay, this is like the biggest person that you can find. That person's 7 feet tall, and they are perfectly round, so they're just nothing but a giant ball of hair, pretty much. Okay, no other human being will have more hairs than this. So the maximum number of hairs that is possible is roughly 221 million. Now, remember, we had 7 billion people to begin with, which is significantly larger than this amount. And since n is 7 billion and m is roughly 221 million, then n is going to be greater than m, which means the pigeonhole principle will apply. So pigeonhole principle applies. So some 2 people will share some number of hairs. Okay, I cannot tell you which 2 people, and I cannot tell you how many hairs they will have, but I know that there are 2 people on Earth sharing the same number of hairs. Okay, again, it's a ridiculous kind of problem, but that's the power of the pigeonhole principle. It can prove things like that. Okay, so basically what happened in this problem is this. First, I had a set that represents the people in the world. Then I had another set that represents the number of hairs possible. Okay, so I'm calling it hair value. And so basically, let's say your best friend John is the first person that we're gonna write. So John is human 1, and he's got, let's say, 0 hairs. So perfect, we're gonna make a function that basically describes how many hairs he's got. Okay, then we have Smith. Let's say he's person number 2 on Earth, and he's got 1 hair. So we can make a list of all the people, and eventually there's gonna be the 7 billionth person, whatever that person is, person X. And let's say that person is gonna have the maximum number of hairs in this case, which is 221670777. But okay, well, is that gonna happen? Can that ever happen? No, because 7 billion is way larger than 221 million. So that means that somebody in this list right here will have that number of hairs, and then the list is going to continue, and all these people are going to have to share hairs, numbers that already had an arrow to them. And maybe that 7th billion person will start sharing the number 1 again, or maybe that 7th billionth person will share the number 5 again, or something like that. So basically what we're saying is that the function cannot be 1-to-1. In other terms, since this first set in red is significantly larger than the second set in blue, some of these arrows will have to go to the same number. So maybe the number is 1000, and 2 people are going to have that same number. I cannot tell you what the number is. I cannot tell you which humans those people are, and I cannot tell you what the number here is going to be. But I just know that some humans that I don't know who are going to have to share the same number of hairs, which is I don't know what. That's basically the pigeonhole principle.